This video is going to do some practice questions with you on sequences. So let's talk about a sequence in general first. In your previous two videos, you learned about arithmetic sequences and geometric sequences. Remember that arithmetic has a constant rate of change. It's adding and subtracting. Geometric has a percent rate of change. It's multiplying and dividing. You also learned about the difference between explicit sequences and recursive sequences. So an explicit sequence is a formula to find any term. They can be arithmetic, they could be geometric, they could be neither of those as well. So for example, if it's arithmetic, it would look something like this. If it was geometric, it would look something like this. And then something that's not geometric or arithmetic might look something like this. Recursive sequences, you use the previous term to find the next term. So if I want to find the 15th term, I need the 14th term. And to find the 14th term, I need the 13th term, and so on. So these sequences can be arithmetic, geometric, or neither as well. But what's special about a recursive sequence is it always has two pieces. So it has to give you an initial or starting term, and then your sequence would look something like this. If it was arithmetic, it could look something like this if it was geometric, and then it could look like this if it was neither. So today's lesson or video is going to be mixed practice. So you're going to need to know, is it arithmetic or geometric? Is it recursive or explicit? And that's actually going to help you with a lot of these questions to eliminate some answer choices. So in your packet, we're on page 11. And our goal is at the end of 42 minutes, I can practice explicit arithmetic sequence, explicit geometric sequences, and recursive sequences. Your do now says, given the following multiple choice answers, create a question. And we want answer choice 3. So take a minute, pause the video, give it a try on your own. So what you should notice about answer choice 3 is that the starting value is 4,000. So you should have referenced something like that. And this is geometric because it's multiplying. And it's decreasing, so you should be losing value because this is actually decreasing by 30% because 1 minus my percentage would give me that 0.7, which is in my formula here. So you could say something like the value of a used car depreciates by 30% each year. A ball is bouncing and only reaches 70% of its height, something like that. You also want to refer to that 4,000 as well. Let's jump into the practice problems. We're going to go through a few of them together, and then the others you're going to do on your own. So if you stay with me in the video, I'm going to jump around and skip some questions. Number 1, when a ball bounces, the heights of consecutive bounces form a geometric sequence. The height of the first bounce is 121 centimeters. And the height of the second bounce is 88 centimeters. Assuming this pattern continues, write an explicit equation for a sub n, the height of the ball on the nth bounce. So if you notice, I took some notes as I read the question, which I always recommend you do. I circled geometric. I wrote a sub 1 equals 121 and a sub 2 equals 88, and explicit equations. So that means I can go to my reference sheet and the formula is going to say a sub n equals a sub 1 r to the n minus 1. I already know a sub 1, so I'm going to plug that in. I don't know r, and n stays in the formula. It's like your x in an equation. So to find r, you have to divide two consecutive terms. So I'm going to do 88 divided by 121. So I'm going to go to my calculator. 88 divided by 121. I get a repeating decimal, so I'm going to hit math, enter, enter, because it didn't tell me to round, so I want to get an exact value. So I'm going to use 8 over 11 as my common ratio. So I'm going to plug that in here. And that's part A. Part B says use the formula to determine the height of the fifth bounce to the nearest centimeter. So fifth bounce, that tells me that n equals 5, and nearest centimeter means a whole number with no decimals. So if you want, pause the video, give this one a try on your own, and then you can hit play to check your work. So I'm going to copy down my formula from part A, and then I'm going to plug in 5. And then I'm going to go to my calculator. 121 alpha y equals, to get my fraction, 8 over 11 to the exponent of 5 minus 1. I'm going to get 33.85 and so on. I always write down my unrounded answer first. Whole number, so I go one past it. That tells me to round up, so 34. We're going to skip number 2, go to the next page, and we're going to try number 3. Savannah just got contact lenses. Her doctor said she can wear them for 2 hours the first day and can increase the length of time by 30 minutes each day. If this pattern continues, which formula would not be appropriate to determine the length of time in either minutes or hours she could wear her contact lenses on the nth day? So I have to come up with a formula for hours and minutes. Now, if I am increasing by 30 minutes each day, that means that a sub 2 is going to be 2.5 hours because I added 30 minutes, which is half an hour. A sub 3 would then be 3 hours. So this, hopefully you recognize as an arithmetic sequence because I'm adding 30 minutes or a half hour each time. So I'm going to actually use this sequence that I just created in hours, and I'm going to go to each of my answer choices and see which one works, or you can go the opposite way and you can actually create the sequences on your own. So I'm going to go to choice 1. It says a sub 1 equals 120. I'm going to hold off on this because the 120 must be in minutes, so I'm going to wait on that. Choice 2, it says a sub n equals 90 plus 30n. So I'm thinking also this is probably in minutes, so I'm going to hold off on that and I'll come back to it. Choice 3, a sub 1 equals 2. That's in hours, good. A sub n equals the previous term plus 0.5. That's good, it works. So I'm going to cross off choice 3. choice 4, I'm going to go to 2.5 plus 0.5n. So I'm actually going to put this in my calculator, and I'm going to try to find a sub 1 using this formula. 2.5 plus 0.5 times 1. 2.5 plus 0.5 times 1. A sub 1 equals 3. Which does not match. So I think my answer is 4, but I like to just double check, especially on not questions. So I'm going to go back to the minutes. And the first thing I'm going to do is I'm going to take each of these and I'm going to put them in minutes. So in minutes, A sub 1 would be 120 minutes. A sub 2, I'm adding 30 minutes, so I have 150 minutes. A sub 3 is then going to be 180 minutes, and so on. So I'm going to go back to choice 1. A1 equals 120 minutes. Good. A sub n equals A sub n minus 1, which is the previous term, plus 30 minutes. That works. It's not choice 1. Choice 2. A sub n equals 90 plus 30n. So I'm going to plug in 1. A sub 1 equals 90 plus 30 times 1. I'm going to go to my calculator again. 90 plus 30 times 1, 120. That one works. I'm going to try A sub 2 just to be safe. I'm going to scroll up in my calculator, hit enter to copy and paste, change my 1 to a 2, 150. That works. So it looks like choice 2 works like I thought. So my answer is choice 4 because it wanted which one does not work. Okay, question number 4. Given f of 9 equals negative 2, this is the same thing as a sub 9 equals negative 2, just so you know. Which function can be used to generate the sequence negative 8, negative 7.25, negative 6.5, negative 5.75, and so on. So this question has a calculator shortcut, which I want you to pay attention to. You're going to type the sequence formulas, which is our multiple choice answers, into the y equals on our calculator, and we're going to go to the table. But first, I'm going to set up my table here so I know what I'm looking for. So my n is my term number, and my a sub n is the actual term. And that's the same as if I had an xy table. So they told me the first term is negative 8. The second term is negative 7.25. The third term is negative 6.5. The fourth term is negative 5.75. And I'm also going to add this one that they gave me over here. The ninth term is negative 2. So now I'm going to go to my calculator. I'm going to go to the y equals, clear out anything I have in there, and I'm going to type in answer choice 1. Negative 8 plus 0.75, and I'm going to use x instead of n. I'm going to go to my table by hitting second graph. Is the first term negative 7.25? No, that's not the table I'm looking for. Cross off choice 1. Let's go back to choice 2. Calculator, y equals, clear it out. Negative 8 minus 0.75 parentheses x minus 1, close my parentheses, go to my table again. Is the first term negative 8? Yes. Is my second term negative 8.75? No. So I'm going to cross off answer choice 2. I'm going to go back to my calculator, go back to my y equals, negative 8.75 plus 0.75x Go back to my table. The first term is -8, good. Second term, -7.25. Third term, -6.5. If you look at all of them, they work even down here at the -9, at the +9, -2. So that means choice 3 is my answer. Moving on, we're going to skip number 5. We're going to take a look at number 6. The population of Jamesburg for the years 2010 to 2013 respectively was reported as follows. How can this sequence be recursively modeled? So remember, if I'm doing a recursive sequence, that means I must have two pieces. I have to have a starting term, and I have to have a formula using the previous term. So which two do you think we're going to cross off? We should be crossing off 1 and 2. These are explicit formulas. Now I'm going to look at choice 3 and 4. They both give me the correct starting term, and they both use the previous term in the formula. So now the question is, am I multiplying by 1.0037, or am I adding by 937 each time? So pause the video, take a minute, see if you can figure out what's happening between terms. So hopefully you chose answer choice 3. And actually I forgot a 5 here. We are multiplying every time. Now, what's important here, and I want you to make note of this, it must work for every term. And that's super important because I want to look at actually the wrong answer first. This says I'm taking the previous term and I'm adding 937, which is true between the first two terms. But is it true between the next two terms? In my calculator, if I take my second term, 250,937, and I add another 937, I get 251,874, which is not my third term. So that's why it can't work. While I'm on my calculator screen, I'm just going to show you that choice 3 does work. 250,000 times 1.00375 gives me 257,937. If I take that number and multiply it by the same 1.00375, 251,878, it works for the third term. If I take that number and multiply it again, I get 252,822, so it works for all the terms. So be careful when you're doing these. You have to make sure it works for every term. So number 6 was choice 3. We're going to skip number 7 and 8. We're going to go down to number 9. A recursive formula for the sequence 40, 30, 22.5, and so on is, take a minute, pause, and try this one on your own. So recursive formula, once again, I should cross out 1 and 3 because those are explicit formulas. And this is very similar to the last question. Am I subtracting 10 every time, or am I multiplying by 3/4 every time? And hopefully you paid attention in the last question because it must work for every term. Both sequences work for the first term to get from 40 to 30. You can either multiply by 3/4 or you can subtract 10. But only one of them works for the next term, and that is choice 4. We're going to skip 10 and 11. Let's take a look at 12. In 2010, the population of New York State was approximately 19,378,000 with an annual growth rate of 1.5%. Assuming the growth rate is maintained for a large number of years, which equation can be used to predict the population of New York State T years after 2010? So, in this case, it does not specify it does not specify explicit or recursive. So I cannot eliminate answer choices based on that. Now, what I do know is that if I'm growing by a percentage, that means I have to do 1 plus the percentage. And my percentage needs to be converted to a decimal. So this is going to move 2 places and become 0.015. So 1 plus 0.015 gives me 1.015. So with that information, I am going to go right ahead and cross off choice 1 because it has the wrong decimal. I'm also going to cross off choice 3 because it has adding and it has multiplying. And in this case, I'm growing. I should just be multiplying. Now the question becomes, is it choice 2 or choice 4? So it says T years after. So I want to find the first year, which is going to be P of 1. And in order to find that, I'm going to take my original population, which we're going to call P0, and I'm going to multiply it by 1.015. So in my calculator, and type that in. There is my population for 1 year after 2010. So this is 19,668,670. So this is 1 year after. So that's T equals 1. Now, if you notice, what I actually did right here in order to find 1 year after is choice 4. So choice 4 is my answer. But if not, you can check choice 2 in your calculator. Go to your calculator, go to the y equals, type this in, and go to the table. You're not going to get this value for 1, okay? And then the last question that I'm going to do with you guys, we're going to skip 13 and 14. We're going to go down to 15. Which scenario could be modeled using a geometric sequence? So geometric is a key word. So when I hear geometric, I think like word association. I'm thinking multiplying or dividing. I'm thinking exponential function. And I'm thinking percent rate of change. So choice 1, a water tank is filled at a rate of 2 gallons per minute. That would be adding 2, so that would be arithmetic. It's not choice 1. A vine grows 6 inches every week. That would be adding 6, arithmetic, not choice 2. A species of flies doubles its population every month during the summer. That's multiplying by 2, so that looks good. I just want to double check choice 4 always. A car increases its distance from a garage as it travels at a constant speed of 25 miles per hour. So constant rate of change would be arithmetic and linear, and that would be adding 25. So we were correct. It is choice 3. So you're going to complete the other examples that we skipped and submit those. And then there's 2 extra pages of practice. if you want to do some extra practice from even that.